Hey guys, welcome back to the lab. Today we're on to AC circuits. What you're going to do is see me hook up an AC data collection setup. That's going to involve putting computer probes around the resistor. Pay attention to how I incorporate that, how I incorporate the diode. The main thing you're going to want to do in this one is to make sure that you look at the data acquisition. So we're studying a fast-moving thing, and we're going to set up some fast-moving data acquisition. We're going to dive right in. See you in a minute. So we're going to begin by taking a look at our voltmeter probe. We're going to use it just as we had it set up before. You can see I've got the black in the common. I've got the red probe in the volts ohm setting. What we're going to do this time is to use the upper right quadrant here, and we're going to swing this indicator over to the 250 volts AC. Well, why are we going to do that? Well, we're going to use it for two things. First thing is just for fun. What we're going to do is take these probes and actually back them out and stick them right in an electrical socket. You know you want to. Let's do it. So we're going to go ahead and do that, and no, just kidding. Nothing's happening. Go and see how your mileage varies. Big thing you should know is this is going to measure an RMS value for the voltage in the lab today. But go ahead, double check me, see how that works out. We're going to then take these probes and use them in the lab itself. Okay, so here's the setup. We've got our power supply, it's plugged in. What we're going to be doing is using this side of the power supply over here with the two reds because we're doing an AC circuit. The first lead you're going to install is very simple. You just go ahead and plug this in here, and you connect that to a resistor. And then we take that alligator clip, the other side of the resistor, and run that right back to the power supply. You know what? There's no way to do this wrong. They're both hot leads here. There's no ground, particularly, in this setup that you can see. So what we're going to do, set that guy down. And I'm going to show you now, once we've got that rigged up, how to use your voltmeter. So when we turn this power supply on, we're going to be getting some number of volts. And this is a nominal reading you're seeing here on the power supply. It might be 2, 4, I don't know if you can make that out, but 2, 4, 6, 8, 10. So you want to put it around somewhere between 4 and 6. And we're actually going to measure the RMS value that we see by going back to our ACV. So I've got that on ACV, and I can actually stick these in. It doesn't matter where. With one hand, it's a little trickier for me, but I just go ahead and gently push upwards. And you can see the 4 volt setting that I've got this on is reading dead on at 4 volts. Okay, so the voltmeter part is done. What I'm going to do is pause and go ahead and grab the computer stuff that you need to get this whirling. Okay, so what I've got here is a LabQuest Mini with one end, the USB end, plugged into my computer. And I've got the other end, which is the voltmeter leads, which just look like a hunk of wires. I've got my red lead and my black lead, and that's all they look like. So what I'm going to do is find any analog channel here. That's channel 1, 2, or 3 on the side, and just go ahead and plug those guys in. Only one way to do it. And I'm going to set that guy down now and show you how to make this connection to your resistor. So this is very, very simple. There's also no wrong way to do this one because this is an AC circuit, and there's no side that's more grounded than the other. Okay, so we're just going to set that aside on the power supply and then dive in on the actual computer and show you what that looks like. Okay, so what we've got here is our screen. We've got voltmeter probe plugged in. The next thing we're going to do is just turn on the power supply with a flip of the switch and hit spacebar or collect to start some collection. And what we're going to get here is absolute garbage data. Now we're looking for something that looks like a sine wave. That's what the textbook said. So what we're going to do is stop that and talk about why it's important to study the thing that to understand the thing you're studying before you plug it in a computer and start studying it. So 15 seconds is how much data we're taking here. That would seem like the long, long time in the life of an AC signal. So what we're going to do is dive into experiment. Go to data collection, and if you've done the pre-lab questions the way you should have a clue what the Greek letter omega stands for. It's called angular frequency, but any more than that, I'm not going to tell you. What I'm going to do, though, is show you how to get the data collection. I'm going to take 1 second worth of data, and rather than 10 seconds, or 10 samples per second, as you can see here, what I'm going to do is I'm going to up that to be, see if we can get away with 1,000 samples per second, and see what happens. We'll click Done. We're going to check again that our AC is still on, which it is, and if I leave it on for too long, you're going to smell it. But we're going to press Data Collect, and we've got now 1 second of a solid block of red. Okay, that's actually what we're looking for. I'm going to turn off the power supply. I'm going to go ahead and now start to work with this. I'm going to go out to the very end of Logger Pro here and tell it to be, rather than 12 seconds, tell it to be 1 second. And now you can begin to see a sine wave. What I want to do is, in fact, let's zoom in a little harder and see if I make this, I don't know, maybe 0.2 of a second. Now I can really see a sine wave that makes sense. Now, there are two things we're going to do with this. This looks like 1, 2, 3, 4, 5, 6, maybe 10 periods of a sine wave. The first thing we're going to do is we're going to go to Analyze, and we're going to curve fit this data with an appropriate kind of curve. So Logger Pro gives us a lot to choose from. We're going to go down looking for something that's trigonometric. And what we find is A times the sine of BT plus C plus D. In this lab, your job is to look up the theory and to match the numbers here for A, B, C into real life. So we're going to try the fit, and the overlay looks perfect, and the overlay is in fact perfect. You're going to take a screenshot of this information, and you're going to use it. So I'll do that right now. Command-Shift-4, capture your whole screen, or at least the data and the sine wave part of it, and then we're good with that. The second thing we're going to do is we're going to click with our mouse, and we're going to start at the top, or as nearly as I can get it, the top of one of the sine waves, and then I'm going to count. Let's see. That would be 1 whole wave, 2 whole waves, 3, 4, 5, 6, 7, maybe 8 whole waves. You can do it. You can read the instructions and follow it for yourself. And what I'm going to do is go to Analyze and just get statistics on this. So what it just did was to give me statistics for the sample that I collected. The minimum was 6.085. The maximum was 6.075. The mean was very, very close to 0. You'd want to be thinking about that, okay? So we're going to take those two things and bring them home to the bank. That will be the analysis that you do for the lab. Now that we've got the data analysis done, we're going to jump onto the second part of the lab, which is very, very fast. I'm just going to close this down for you so you can see it. I'm going to momentarily disconnect the voltmeter leads because I don't need them. And what I'm going to show you is that we're going to make a very, very simple series connection here. In the last part of the lab, you're simply going to see what does a diode do. So you're going to grab from this box a thing called a Fahnestock clip. We're going to clip that little Fahnestock onto there. And what that does is it creates a little space so that I can run my diode. Now, one of the things you'll notice about the diode is that there's a little stripe on it. Now, we'll talk a lot later about what the meaning of that stripe is, but for right now, it doesn't matter which way I put it. We're just going to go ahead and expand this circuit. So I've got a series. I've got two things in a line together, and I'm going to put my power supply right here again. So I've got AC power supplied back and forth across this series. Again, what I'm going to do is go up with my voltmeter leads, connect to either side of the resistor, turn this guy on again, and just repeat the data collection that you did a second ago. Flip this power supply on, turn this guy on, and learn what does a diode do. Okay? So that's your lab experiment. See you on the other side. Take care and have a great day.